of the most interesting structures in the entire nervous system. Is one that gets very little coverage, unfortunately. In fact, most neuroscientists aren't aware of what its function is, and it's called the AMCC, which is the anterior mid-cingulate cortex. You have one on each side of the brain. The name isn't really important, but we want to, to the credit of the structure, we should name it the AMCC. The AMCC receives inputs from a lot of interesting brain areas related to reward, related to autonomic function, so how alert or sleepy we are, to prediction error. It's a hub for many, many inputs and outputs, hormone systems, etc. Beautiful experiments done by my colleague Joe Parvisi at Stanford have shown that if you stimulate this brain area, a tiny little brain area in a human, they immediately feel as if some challenge is impending and they're going to meet that challenge. It's a forward center of mass against challenge response. This has been seen in independent subjects. They do controls where they then tell them they're stimulating, but they're not actually stimulating, and they're like, I don't feel anything. You can turn on and off tenacity and willpower. So there's literally a hub for this. Now, here's where it gets really interesting. I'm going to list off a bunch of peer-reviewed published results in rapid sequence, and I'm happy to point out the substantiation for this, or the references. Okay. Individuals that are dieting or resisting some sort of tempting behavior and are successful in doing that, the size and activity in their AMCC goes up over time and the structure gets bigger. Dieters who fail, flat or downward trajectory of the size and activation of the AMCC. This can be taken too far. Individuals with anorexia nervosa, the most deadly of all psychiatric disorders, where a self-deprivation of food activates excessive reward. There's this kind of loop of reward. Their AMCCs are significantly greater size than others. So there's, this can be taken too far. Super agers, which is a bit of a misnomer because these individuals are people who maintain healthy cognitive function similar to people in their 20s and 30s into their 70s, 80s, and 90s. Their AMCC maintains or increases in size into their later years. Typical agers, the size of, we always hear that you lose brain mass across your lifespan. Well, most of it is from the AMCC. And beautifully, and this is two of my favorite results that really bring this around to a protocol or a takeaway. If people are given an easy task, the AMCC isn't activated. If they're given a hard task, in particular a hard task, physical or cognitive, that they really don't want to do, the AMCC levels of activity go through the roof. And here's what's really cool.